I wanted to record a quick video here to show us and remind us how to use the TI-Nspire to solve these systems of equations. We had talked in class how we can create an augmented matrix based on a system of equations, and the augmented matrix here on the right hand side simply comes from the coefficients of our variables on the left side of the equal signs and what the equations are equal to on the right. And when we use this method, it's important to have the values that we're equal to on the right hand side. That'll make the row operations make more sense in the calculator as we move forward. But again, if you look at the coefficients, we have a +1, +1, and -1. So I'll use those three numbers to start the first row. And we have the value that the equation is equal to, 6, on the right. Here we have coefficient of 6, -5. No z value reported, so it's important that we use a 0 as a placeholder for that. Now, if we build this augmented matrix like this, then we can switch over to our TI-Nspires. When we turn them on, we'll create a new document, calculator page. And the shortcut that we mentioned in class was menu 7-5. That brings the reduced row echelon form command into play. And then press menu 7-1-1, and this will create a matrix inside that command. Now this particular matrix had 3 rows and 4 columns. We'll press OK, and now we can fill that in. While using the computer, it's super fast. We'll type 1, whoops, let's see if I can get my cursor active here, 1, and I'll tab over, press 1, -1, 6. But even on the calculators, the handhelds in the classroom, it goes pretty quick too. I think you can press the right arrow or the tab key to move between these spaces pretty quickly. So again, I'm just pressing the tab key between each number that I enter. And now I have the reduced row echelon form command prepared to be executed against the augmented matrix that we just established a second ago. And if what I have in the calculator matches what I had on paper, then I feel pretty confident with this. We'll press enter and proceed. And the results here look pretty wild since we have this kind of, we have 1s down a diagonal here with 0s surrounding the rest of the left-hand side of this matrix. This is effectively saying that we have 1x plus 0y plus 0z equals this fraction, and so on. 1y equals this fraction, and 1z equals this one. So we've effectively applied all the row operations to isolate variables, and we now have the solution for x, y, and z. So utilizing the row operations and completing this by hand, even if you had a calculator available without matrix operations, that still can be a bit of a challenge. So I don't expect to ask this particular question on the test, but it's good to know about the procedure. Perhaps it'll turn into a bonus question down the road. Let's look at another example. Here we've got another system of equations. We've got 3 variables, but this time we've got 4 rows of equations. So let's see what happens when we enter those. Go ahead and pause the video and try this one on your own. Report back in a second and you can see what I've done. So this is the augmented matrix that I would report for that system of equations. We had a coefficient of 1, -1, -1, and then that equation was equal to 4, and so on. So here we have the augmented matrix written inside the reduced row echelon form command. If we press enter to see the result, let's see what we get. Now while this result looks nice because we have 1s down the diagonal and 0s everywhere else, it's a bit of a nonsensical result. If we use the reporting pattern from before, where 1s down the diagonal indicated 1x, 1y, and 1z, this almost implies that we have an x value that's equal to 0, a y that's equal to 0, and a z that's equal to 0. And if that were the case, then, well, back substitution to check our work wouldn't work at all. If x, y, and z were all 0, then we would never have an equation equal to 4. Additionally, we have this final row, which seems a little bit odd to see at all. 0x, 0y, 0z equals 1. Again, a bit of a misleading solution. So I would report this as an inconsistent system, and we'll move on. We'll talk about how to address this at a later time. So hopefully the talk on using the TI-Nspire to solve these matrix problems, the systems of equations, helps you out a little bit here. Please let me know if you have other questions when we see each other in class. Thanks.